All right. You guys can hear me, yes? Yes, okay, I see heads nodding. Okay, so my name is Kyle. I am the leader of our systems engineering group over at Bill.com. We're going to talk a little bit about Bill.com if you haven't heard of us, but we are essentially the #1 small business bill payment provider. We make it simple to pay and get paid. So we are technically a startup. We, privately funded, but we've been around for over a decade. The company has been established, been growing very rapidly, and so essentially we're moving from our on-premises data centers and colos and all of the stuff that comes with that, moving into the cloud. This talk is all about our journey to the cloud, specifically around SageMaker and Glue and S3 and how we leverage AWS services to build what we call our data platform, which is essentially a data lake, but also the SageMaker components that get added on top of that. Okay, everyone at the right session, everyone happy? Okay, this is what we're gonna do. All right. Let me move this. All right. Great. So the agenda today is we're going to essentially talk about why we need machine learning. You're just a bill payments company. Why is machine learning important? What is the Bill.com use case? We're going to go through the old ways, how we sort of did machine learning in the past on-prem, and then how we built the secure data lake inside of AWS. And then we're going to go through our SageMaker pipeline as well. As Mikey mentioned, we also have the Slido. Please ask questions. This is a fairly short presentation, hoping that we can go through it, but then also interact. So if you have questions about our architecture, I also plan on explaining some of our learnings, some of the things that we discovered along the way, because this is definitely new. I mean, it was really fun. Andy went up there today and said, 10,000 people have a data lake, but if you don't have one, it's actually not that easy to just turn on. The new services they announced today to actually help with that didn't exist. So we had to build it ourselves. We had AWS help to try to build it the right way, but ultimately, I come from a systems background. I am a former rack hugger, self-proclaimed former rack hugger, recovering sysadmin, right? So I come from a sysadmin background. I am not a machine learning engineer. I am not a data scientist. My job is to keep Bill.com customer data safe. My job is to keep it operating. I'm in charge of the site reliability, operations, production, all of the systems and network. So my #1 goal in building a lake is making sure it's secure. So this talk is going to focus a lot on the security aspects of the data lake, as well as a little bit about how the machine learning pipeline works, but ultimately we're going to dig into just how we actually secured it. Awesome. Okay. Why does Bill.com need machine learning? We are actually a company, and if you've ever used, if you have a personal bill payment service, it's fairly simple, right? If you have Chase, you go onto the Chase website, you pay a bill, right? You go on there, you say, okay, I want to pay a bill, recurring payments, you're done. Small business owners don't get to do that. They have a lot more complexity around their bill payment process in order to either pay or get paid. A lot of times, they're either receiving invoices or they're paying invoices. As a result, we import all of those invoices into our system for tracking. Sometimes I joke that Bill.com's a lot more like Dropbox than PayPal because of the amount of documents that we actually store. We have terabytes of documents within our system in order to track, everything from invoices to contracts to any kind of thing that's uploaded. These documents are random, unstructured, completely formed in whatever way a customer ended up publishing it into the system. As a result, if you ever have an invoice, they're all different formats. QuickBooks has a different invoice format than, say, your Amazon bill that you get from AWS. Every invoice is different. Our system needs to not only recognize the type of invoice that comes in, but then even an unstructured format. If you had an invoice that comes in, what is the due, what is the total due amount on the invoice? What is the due date? We can't have invoices paid late. So if the system recognizes the document that's inserted, we need to be able to use machine learning to actually recognize what is inside the invoice and when it needs to be paid. Also need to determine the vendor, who needs to get paid. You don't want to pay the wrong person. That would be bad. The second part about Bill.com is that we manage over 1 million transactions a month. through our payments platform, and we have over a $60 billion payment volume that flows through our platform. The reason I say this is essentially to emphasize that security is our #1 goal. We have a security team, we take security seriously, and we have dedicated engineers on it. It is important for us, as we went through the machine learning exercise, we had that mindset. A lot of times when you're building a data platform and a data lake, it's something that you don't have to worry as much about, but for us it was key. So we're going to talk a little bit about that later. Customers expect all the data entry to be automatic, okay? So who uses something like Concur or Expensify? Who's going to do that thing when they go home? Yes? Okay, I have to do that. If you ever do that, you upload a document into Expensify, you want it to be accurate, you want it to be fast, and you don't want to type anything. Small business owners are the same way. When a small business owner is using our platform, although we have an awesome platform and we want them to use it, they want to get in and out. They want to process their bills so they can go back and actually run their business. They're not there to go do all this. That's why they have Bill.com, is to spend less time on managing their invoices and payments. So auto data entry was super important. Manual entry by humans is expensive. You may know that a lot of folks in this field, if there's a lot of automated processing, OCR has been solved a long time ago, right? A lot of companies can do OCR, but what customers need is something a lot more advanced than that. So some companies will outsource the actual manual data entry of their documents into a third-party outsourcer that's like maybe onshore or offshore. There's different providers that can help do that. AWS provides stuff like Mechanical Turk to help with that sort of thing. But that is expensive. That option is very expensive. And then the other issue with that is that it's slow. And we can't have processing of these documents to be slow. Okay, everyone with me so far? Everyone gets it? Okay. Awesome. All right, we're going to talk a little bit about the journey. Before, machine learning was performed entirely on-premise. We would lock all the data away. So, so we have all our data centers, all the data is all protected, it's secure, none of the bad guys can get it, which is awesome. However, if you have spent 10 minutes working with machine learning engineers, they want all the data, right? They're like, I need all the data. It's actually more data than the traditional, I would say, the business analytics people would have required, right? In the past, you had a data warehouse, and you're like, oh, I'll just pull some data out of the data warehouse. For machine learning engineers and data scientists, they need all the raw data. So for us, one of the big challenges is around how do we take our on-premise Oracle databases and actually provide data science and machine learning on top of them. So what we ended up having to do are manual extracts. So we actually had to look at Oracle, extract it into another Oracle database that was also on-premise, and then give the data scientists access to that. That process was super slow. And if you ask our data scientist how that process went, he would not have a very happy response. You'd say it took too long, there's too many security approvals required, there's too many exceptions required, and not good at all. So what did we do? Our journey to the cloud was essentially to take these manual extracts that we were performing on-premise and say, okay, well, we've built a model. We're actually on our 3rd generation of machine learning now. And we've already built a model, so how do we leverage AWS and SageMaker to actually host that model? So we actually started there. We started using SageMaker on the inference side. We didn't actually start using it to build our models. We said, well, we already have it. So we took the model, threw it into SageMaker, and actually were able to execute moving that into production fairly quickly, on the order of a couple months, as opposed to many months to actually, if we were to build our own service and actually create our own Python extraction microservice to actually do all the inference and all the processing for the machine learning, then it would have taken a lot longer. And as an operations engineer, I'd have to set up services, had to complete all the dependency, all of the monitoring, everything. For us, it was a lot easier to just host it directly in the cloud. And I'm going to show the architecture later so you can see sort of how that works. Okay, as I mentioned, I'm an operations guy. Security is important. I focused a lot on how do we actually protect the data. I'm sure if you've been at this conference now 2 or 3 days, you hear everyone says S3 is secure, right? S3 is secure, and I actually agree with that. AWS provides a very secure platform with S3, but out of the box, it is not perfect. right? And so what we did is we worked with AWS to provide the best security around those S3 buckets that we could. We decided from the beginning it wasn't sufficient to just say, oh, throw the data in a data lake and call it done. So these are some of the policies we implemented. The first is a bucket policy requiring only specific users to have access. By default, an S3 bucket just gives everyone in the account access. For us, we wanted fine-grained access control. For us, we have both machine learning engineers, data scientists, operations people, and different roles within the company. So for us, we utilize these roles, and then we say only allow these specific role IDs to have access to this bucket. That was the first thing. The second was we had specific roles that were created around SageMaker and Glue and gave those roles access to the bucket. That allowed us to give separate. So SageMaker needs certain things to actually build the model, and Glue needs certain things in order to actually extract as a part of the data lake. The next part is around KMS and encryption. Encryption is really important. By default, S3 has a default encryption through the SSE KMS. You can just check a box and it's on. However, the default encryption provided by AWS was not sufficient for us. We wanted to have more fine-grained control about who was allowed to encrypt and decrypt data. So what we did was not only require KMS encryption and SSL encryption on the bucket, but we required a specific KMS key for that bucket and said this key is required to actually access this bucket. And then we also had to provide, if you've ever worked with KMS, in addition to bucket policy permissions, you have to provide KMS permissions so that we have specific permissions around what users are allowed to encrypt and decrypt data in the bucket, as well as who are the admins on those keys. Having your own KMS allows you to get a little bit more fine-grained about your keys, the rotation policies and other things that you wouldn't be able to do on the default policy. Okay, the next is evaluating fields. So for us, a lot of the time that was spent in building this was building all the fields, building all of the data that was required to actually place in the data lake. So we spent a lot of time building our own scripts to actually extract the data and one by one, field by or column by column determine which columns are required to actually insert into the data lake. We didn't just willy-nilly say, oh, just throw the whole thing in there and just assume. So for us, we actually started small. We said only non-PII, non-sensitive data is allowed into the data lake. And we'll start there. We're going to get comfortable with it. And then as we get more comfort, then we're going to go ahead and add more sensitive data once we feel like it's good to go. So remember, we're on this journey, right? When you start in the cloud, it's a different story than when you're trying to move on-premise to the cloud. We have a lot of compliance regulations. We're anti-money laundering, OFAC. We have to be money transmitter licensed in all 50 states, PCI certified, internal audits through SOC, external audits through banks. It's very important to us that we not only protect the data, but we protect our partnerships and our brand. Last is Okta. So Okta we use as our single sign-on. Is super awesome. We like Okta, and we use it for all the federated roles. We said that only the SageMaker and Glue roles are great, but that's only within the AWS services. The actual Okta SAML is used for any, I should say, humans. So if you're a human, you should be using Okta. Even if no matter what administration function that you're doing, we use Okta and separate accounts in order to determine whether you're pre-production or production. All right, everyone with me? Awesome. Okay, we're going to go through the first part of the platform. First part of the platform is all about how did we manage the data lake. This is the actual data lake, data platform that we built. There are 3 different entities involved here. There's a corporate data center, that's the thing all the way to the left. This middle section is our AWS account that we call the data lake. And then we have on the right, we have an AWS account that's actually running for production. So if you remember, and we'll kind of start from the left and move over to the right to kind of understand what we're doing. So on-premise, we have two primary databases, our Oracle database and our MySQL database. Oracle is our primary transaction database. MySQL is used for secondary microservices. What we do is we use an extraction from these databases into a master CSV file. We spent a lot of effort making sure that we did this right, and then we found out today that there's just a service that can do it, out of the box, but that's okay. But for now, we built this. Extract everything into a CSV file. Each CSV file represents a table. So every table has its own CSV, and then we extract it. Every day, we then take that extraction, and we use the AWS CLI to actually import all of that data into S3. So remember, none of this data is in the cloud. We have to actually get it to the cloud, right? So that's the first step. Manage it through the CLI, we send it to the cloud. Once it's in what we call the landing zone, that's the S3 sort of left side here, we have our CSV files that encompass both a full extract, and on some of our tables, we can actually do incremental extracts. This landing zone is for operations use only. There's no data scientists, no machine learning people access this. This is just a staging area as far as the first step to actually get into the cloud. Once it's there, we use Glue. So in the past, it used to be data pipeline. Now we have Glue and Lambda. So that is the function that we decided to use. Glue then helps us extract all of the data that we have in CSV into a format that's more AWS, I would call friendly, okay? So number one is we extract it into Parquet. So if you ever use the CSV, right, it's essentially row-based. So every row, like a database, is like, oh, you have all these different fields that are in the row. The Parquet format essentially turns that into a column-based format that's more consumable for data platform, for data analysis. Once converted into Parquet, and then we also use Glue in order to extract for certain fields that are not necessarily that we, like actually transformation of the fields, we can extract into other CSV or Parquet as we need it. Glue is what takes care of all of the catalogs, it takes care of all the crawlers and the scheduling around this piece. There's a little bit more here around, we actually use CloudWatch on Glue to send alerts so that we can actually see the status of these jobs. Inside the data lake, we then need to actually use the data. So now we actually have the data, it's in a usable format. So what we do is we can attach the AWS services on top of it. We use Redshift and Athena. Athena was the first that we used just because Athena is just like a sledgehammer. You can just point Athena at a Parquet, a Parquet formatted bucket, and now you can actually just read your data. It's not fine-grained, there's no importing, you just go at it. And then we use Redshift. Redshift we're just starting to use now, but essentially we're using both a combination of Redshift and Redshift Spectrum in order to determine, we can actually push data in, then we can also access the files directly. The reason that we're using Redshift is the full-on, so we can have the full data warehouse solution. On the right side, it's actually what we do is we take our machine learning engineers. So our machine learning engineers inside of SageMaker Notebook will then access either Redshift or Athena. We also, inside of our data lake, use this data to do all of our analytics. The analytics component is still maturing for us. Our number one use case to start is all on the machine learning side, but in the future it's going to be all the analytics is going to be in there for Tableau and any other data analysis that's required on that data. All right. Sweet. Okay, last slide and then we're going to go into questions. This is all about our SageMaker Pipeline. So the SageMaker Pipeline, if you remember on the last slide, the very right side was this SageMaker thing. So who's used SageMaker? Who's logged into a SageMaker notebook? Nobody? Okay, you gotta be honest, that'll help, yeah, because if you've already done it, you're gonna be bored when I talk about it. Okay. SageMaker essentially is a full service Jupyter notebook hosting platform in order for you to be able to build and train and host your models. Even though we had done machine learning in the past, we actually found this incredibly useful because it takes care of all of the life cycle around the actual machine learning that we need. The machine learning engineers log in from their desktop into the SageMaker notebook. Inside of the SageMaker notebook, we have secured it inside of a VPC. This VPC has no direct internet access, so it is not on a public subnet. SageMaker has the ability to actually spin up notebook instances that are inside of VPC and do not have internet access. So that is what we've done. However, data scientists need the internet. Like, you can't just cut them off. Like, it'd be nice, but they don't like that. The problem is they need to use things like Conda, they need to pull in different Python packages. Although SageMaker comes with a set and pre-built functions of a whole bunch of like TensorFlow and all the different things. At least my data scientists are like, no, I want this. They're going to bring in all their own packages, and they need the ability to get to the internet. So what we do is we provide a proxy. The proxy then provides the whitelist to say what services that SageMaker is allowed to access. That way, they can't just randomly hit some URL that they shouldn't be accessing. So it's a little bit more secure than just simply the default SageMaker, which puts them directly on the internet. In addition, we provide encryption on the SageMaker notebook. You can have encryption on your notebook, and you can specify lifecycle policies to specify your proxy. On the Redshift and Athena side, I talked about a little bit before, but essentially Redshift and Athena are then being accessed into from SageMaker. So the data scientists will be able to go through there, actually through Jupyter, then connect directly into Athena and run queries. One of the learnings we had in this process, like I said before, data scientists want all of the data. So I provided initially all of the data in a CSV file, and I said, here's all the data. You kept saying you want all the data. So I gave it to them. They tried to load it into SageMaker, and the Jupyter notebook essentially exploded, right? It's too much data, too much inside of a single Python instance. It ran out of memory. The data scientist's solution to the problem was, oh, I'll just create a bigger SageMaker instance, right? Let's AWS, right? So, okay, we'll have a P4 24 extra large, like, half a terabyte of memory instance. And then it worked, right? So that was a good workaround initially, but very expensive. So what we did is we are moving towards Athena and Redshift so that they can actually get filtered data a lot easier into what they're doing. Because a lot of times, we have certain tables that are millions and millions of rows. They don't necessarily need all of that data at all times to actually build their models and just play with the data. Because there's the big learning around machine learning is first, you don't even know what you're doing, right? You have to play with it, you have to learn. So a lot of times you're just wanting to do quick things, grab certain subsets of the data, figure out what you want, and then you can actually do the training later. All of the training is provided inside of SageMaker. SageMaker can then load up from ECR, it can load the Docker containers required in order to actually do the training. And then there's a temporary bucket in S3, either for static snapshots of data that we can provide the machine learning engineers so they can actually build it, as well as for temporary storage. Each of our buckets are all encrypted, all using the policies I said before. Okay, now we built our model. Everything is working, that's fantastic, but now we need to host it. So the way our hosting platform works is we take the model, and then we take the Docker container, and then we throw it into a SageMaker instance in production. That production instance is inside of a private VPC. This VPC has no internet access in or out. It is completely locked away. It is like a little shell in like its own little cocoon. For us, this was a great way to just get on the platform. As an operations person, I don't have to worry about any bad guys getting in or anything weird about this system getting out. It is just a complete cocoon inside of SageMaker. If we ever need to update, we can just update the Docker container and deploy it. Okay, that's great, but then how do you actually use it? The SageMaker APIs allow us to execute and infer on our model directly from our data center. The way that works is we create an IAM user. You can't use a role because it's not inside of the AWS platform. We have a user access key within our data center that allows access directly into the SageMaker execution API so it can run inference on the model. It does not need direct access from the Jupyter notebook inside of the actual inference model, the Python code that's running in here, to actually reach out. It can go directly from SageMaker. And that's using the AWS SDK. That way we don't need to actually, a lot of patterns you see are using API gateway in front of SageMaker, which is perfectly fine. We actually just don't need it for now. It just runs perfectly fine just using the execution API. That's it. Okay. Done. All right. I need questions.
Cool. Thank you, Kyle. Let's give him a hand.
Yay.
So we'll turn to Slido. If you have any questions, go to slido.com, use the hashtag startup as a password, type it in there, and then you can upvote other questions you want answered.
Yes.
So the top one, it says, do you evaluate the storage gateway to move data from on-premise to AWS?
Yes. So if you don't know storage gateway, there's like different formats of it. There's like cache gateway, volume gateways, all these different things, which is great. For us, in order for those to work, you need to have an iSCSI volume and a target to put it in there. So we evaluate it. The problem is it's so much data that we're not quite ready for that. So eventually, this is a part of just the overall migration plan for us, but not yet. So mostly we're looking for that for our corporate services, not for production.
Looks like a new one popped up. It says, how are the versions of model deployments managed?
Oh, okay, this is good. Yeah, so the way that we manage the models is inside of that Docker container directly. So initially, I didn't explain really well, but inside of the SageMaker is both the actual Docker container and the model. And so we can actually cut and paste a new model without actually touching the Docker container. When SageMaker starts, it fires up Docker, it pulls in the model. So for us right now, our models do not change very frequently, which is awesome, so we don't really have to do that. That's a manual process, which sucks. Eventually, the right way to do this is essentially we'll use the entire SageMaker pipeline in flow all the way through, and then that way the versioning will come just as a part of that.
I guess let's keep going on the SageMaker stuff since we're on the topic. Where do you output the data produced from SageMaker?
Oh, yeah, so on that slide, so when Bill.com accesses the SageMaker execution API, it is both running the inference and receiving the output from SageMaker. It gets the response from the machine, from the model. It then stores all the output. So we store it all on-prem. It keeps the output, it keeps the input. That way we can improve the training of the model in the future. And then it goes through that cycle. Because we already have the data in our database, it can then flow back into the data lake. Then the data scientists can then use that data.
Okay, let's go to the top. Do you aggregate and share the learning from all your customers or models on a customer basis?
Okay, so in general with machine learning, it's across everything. It generally doesn't work as well specific per customer. So for us, it's across everything. Like it is all customers, all data, in order to actually provide the best model. And we only use a single model for all customers. I can imagine in the future that could change, but that's how it is now.
Go to the top. How do you plan to manage security around your P2 and Athena Redshift situation?
Not sure what specifically around. So the management of the security is around all of it, right? So a lot of it is about encryption. It's about least privilege and access. It's a lot around, making sure that the right data is there. But it's all of that is such a huge. There's this talks here all day about this. I'm happy to talk to you in person about all of it, but it's huge. It all depends on, because we're looking at data loss prevention, we're looking at actual encryption, we're looking at, who has access, how do you keep the bad guys out, how do you keep the good guys from getting out? It's all different angles, so it's
whoever asked that question, you could also follow up after the talk if you wanted.
Yes.
I'm sure I'll give you some of his time.
Yeah.
So how do you transfer data from your data center to AWS?
Yeah, so for now, that's ultimately using the AWS CLI. So we do, just through S3, it has a sync command. So that's how it is. It's just AWS S3 sync all of this stuff, throw it in the cloud. That works sufficient for now. They announced today that they actually have the service that will actually help you do that, which is fantastic. There's also data migration service that can help you do that. We don't use that, but that's also a lot of people who do that.
Let's go to the top. You were talking about proxy access to the internet. Is that via Internet Gateway by AWS, or is it something you built custom, or?
Yeah, so there are two ways to get to the internet inside of a VPC. You can have an Internet Gateway, or you can have a NAT gateway. We do not use an Internet Gateway. Internet Gateway is where you just put a public subnet. That's where you put your ELBs. In this case, that is not what we're doing. We use a NAT gateway, and the NAT gateway sits on a public subnet, and then our actual app instances sit on a private subnet. That app instance only connects to the NAT gateway, and then that's how it gets out the internet. The NAT gateway provides the actual access.
Cool. These can probably go together, so let's start with how often do you retrain your model, and is that an automated process? And also just how accurate is your data capture model?
Okay, so the first one, so how often? So we retrain manually today. I think now, because we're still on the journey for SageMaker, however, what I can see happening is the trading happening a lot more frequently. Because as the iterations get better, it's going to become a lot, because it's in SageMaker, it's really easy to automate. So for now, we just don't have to do it as much. I would say that, I'd guess like 95% of the time is just playing with the data. Like, it's not even like training. It's like trying to figure out what are we going to do with the data, what data is useful, what is the right model to use, and then actually execute the training, and then that's less of the time. What's the accuracy? This is an excellent question. I don't know. Yeah, so it's definitely helped. The accuracy of the models, especially on the document processing side, has gone up tremendously. If you talk to our customers, like I said, we are on our 3rd generation of machine learning. The initial version was rough. It was like 50% or so accuracy. We're aiming though to get 90% accuracy, and so we're somewhere on that spectrum, but we're not there yet. But it's really hard, like I said, because the documents are all different. But it is actually becoming a lot more helpful.
Cool. Last question, it looks like. It says, do you capture line item details as well, or just invoice headers?
We capture all line items. We essentially use, we do the OCR to actually so there's digital documents, like a PDF, and then you have like a scanned document, which is just a picture. So on both of those kinds of documents, we'll extract all of the data, and then we'll use it using the coordinates on the document, and then including all data. So it's all the data that's in there, it's all used as a part of the model.
Cool. Well, thank you, Kyle. Let's give him a hand. That was great.